right? And the Q will be in QZ, and then we have to divide by our what? Thickness. Okay. So this, if you look at this, the trend is Vy divided by IZZ QZ divided by T. T is the is whatever that we have written down here for T. Okay, so for this case, to complete the formula, so this will be equal to Vy over IZZ QZ divided by B. Okay. If we look at the other one, right, it's the shear, right? So now the shear, if we were to look here, now the shear is still on the what? The shear is still on the X plane, but now it's in the what? Z direction, right? Because the shear force is acting in the Z orientation. The shear force is going to be parallel to the what? Will be parallel to the shear stress. Okay, so this will be equal to the shear ZX, right? So now this will be equal to what? So watch this. This is equal to VZ over IYY QY divided by T. So to complete, so you get VZ over IZZ QY divided by 2C. Okay, so you can see now. Okay, you can see now the difference now. Okay, now what is the trend? Okay, what is the trend? The most important thing to remember. Now, can someone tell me the trend between VZ and VY? What trend can you see in these two formula? What trend can you see in these two formula? Anyone?
So if you want to calculate with Vy, you take into account what
I got it. Wait, I got this wrong. Sorry. So so this is not Y. I do apologize. So this is I. Y. Yep. So what can you see? What is the trend can you see based on the formula?
That Vy is acting upon the parallel axis. So
something's more simple than that. There's something very simple that you can recognize, right? In terms of the trend, that it will help you remember the formula. Okay. So the first thing is this. Okay. When it's Vy, you can see this is Vy, right? The I and the Q will be in the what? ZZ orientation. Yes or no? Right? If on the other side, right? If you look at this formula, when you have VZ, you are going to use IYY, right? You're going to use IYY and QY. So don't mix it up. A lot of times, what happens is students get mixed up. Okay, so if you look at the shear, if it's VY, right? If you use IYY, QY, then it's all wrong already. Okay, so that's why I'm telling you this topic is very, very easy. Okay, but the rules, when to use IYY, when to use IZZ, when to use QY, QZ, it all depends on the orientation of your shear force. That's why on the left-hand side, okay, on the left-hand side, what did I highlight? On the left-hand side, analysis for what? BY. On the right-hand side is analysis for what? VZ. Okay. Right. What I'm going to propose is, I know this topic is quite heavy in analysis. We will take a break at 10:30 for us to absorb what is going on. Okay, then we come back at 10:45. That's what I propose. Okay. Jerome say datum analysis is from the central. Yes, Jerome, I'm going to derive that now. Okay, so Jerome make a statement, analysis from datum. He's right. I'm going to derive that statement now. Okay, right.
Sir, I have a question.
Yes.
So I got the concepts about the moments of areas and all, but that sectional view FF, was that given, or like how do we get that sectional view from that beam? Like
yeah, it's given. I make it to be rectangular. It can be circle, it can be a square, it can be an I-beam, it can be a L-beam whatsoever.
Oh, okay.
Does that make sense?
Yep.
Okay, thank you. Right.
Eugene, I have a question related to the second moment of area.
Yep.
Is it always the same formula, no matter the shape?
It will change. This
Okay.
is for what I'm only doing for is just for rectangular. Okay.
Okay.
For circle, it will change. For I-beam is going to be similar because I-beam is made out of different rectangles, right? Okay.
Okay.
Right.
Thanks.
So the next one that I'm going to talk about is we're going to derive. Okay, we're going to derive a certain aspect of the formula. Okay, and when I'm deriving this set of formula, rules will start to appear. Okay, that is why in a university degree, you have to know how the analysis is evolved. I repeat again, that's why in a university setting like what we have now, we have to know how the formula is evolved. Okay, it's not just like, okay, this is the formula, okay, we are good to go, we apply. No. We have to know how the formula has been evolved. And then if and only if you know how the formula is evolved, then you know how to apply. If you don't know how the formula is, when I say evolve, how is it derived? Okay, very, very important at this aspect now. Okay, and this is always useful if you are going to do graduate school or whatsoever. Okay, this will be useful. It's going to do graduate school or in industry. Industry don't hire if you know how to apply. The industry more or less want to hire you if you are an analyst. And I hope to get you guys into having this analysis concept. Okay, because that is what is short of a lot of engineers that my friend hires. Okay, I have friends that are hiring engineers in corporate companies. They say, Eugene, what are you doing in universities? The capability of analysis is equal to 0. And I don't want that to happen to our students. Okay, right. Jerome, you have a question? I see your hand raised. Or you raised it a while ago. You are okay? No. Okay. Okay. Right. You are not okay or you are okay. But it's okay. Anything you ask me, okay? So now again, I'm going to take this figure. Same figure. And we're going to derive this figure. Okay. So what we are going to do is we're going to derive okay, we're going to derive showing that the shear xy is going to shear yx, right? And this will be somehow, so that the maximum value is going to shear yx maximum, and this will be equal to what am I doing? So no. Get rid of the maximum. My bad. I'm not looking at the right thing. So this will be equal to 3 over 2a, right? Vy. Then you have 1 minus by y squared over by c squared. Okay, not like that, but 1 minus by y squared divided by c squared. So remember, like what I said in other courses, right? Math is a language. So if you look at this term over here, right? We know that the bracket term over here, right, will always be what? The bracket term over there, that is a very bad way of the bracket term over here, right? This term over here will always be less than 1. It can be less or equal to 1. So from here, you can immediately state that tau max or tau xy max is equal to shear Yx max, and this will be equal to 3 over 2a, right, at Vy. Okay, so the only way that this will be maximum is this term over here, right? This term over here will be equal to what? 0. Okay, so we know that the shear, maximum shear will occur when, right, y is equal to what? 0. Okay, and then we're going to talk about this. Where is y equal to 0? Okay, where is y equal to 0? Now, let's look at this diagram now. Okay, let's look at this diagram. So we're going to focus everything on this diagram now. Okay, we're going to look at it. We're going to derive that relationship that we see, right? The relationship that we see over here, where shear xy equals shear yx is equal to 3 over 2a vy bracket 1 minus y squared over c squared bracket. Okay, we're going to derive that relationship. Okay, so we're going to look at this diagram over here. Right. So what has been stated is we are having a vy, right? So this is our vy over here. Right. So this is valid, right? This formula is valid if and only if your shear force is at that direction, Vy. Okay. So let's look at the root formula. So let's look at the base formula. So we are going to derive shear stress. Okay. So we know that we are going to derive shear xy. And now all of you know now that this is equal to Vy, right? Over what? Can you remember? Is it Iyy or Izz? Anyone?
Izz.
Yes, Izz, right? Q what?
Z.
QZ, right? Divided by T.
Okay. Eugene, I know that you already touched on this, but I kind of want to remember. It's Vy. No, Vy is not the same as P, right?
Vy can be the same as P.
Okay.
Does not mean it cannot be. It can be the same as P value. Sometimes, not always.
Okay.
Okay, so when you do analysis like this, you have to find the location of your maximum shear force.
Okay.
Okay, so it can be equal to P.
Okay.
Okay. So the shear xy is equal to Vy over Izz divided by Qy. So now you guys know the feel of how to calculate. So the first thing we're going to do is, okay, let's see what we already know. Okay, so Vy, so rule number 1, we're going to apply rule number 1. V and I are constant, right? So that's the first thing that we know. V and I are constant. So the first thing, so we know that V is equal to what? Vy. So next we're going to find Izz. Okay. So what is Izz? What is Izz equal to? Okay. So Izz. So this is our zz direction, right? So anything that is parallel to the zz axis, this is known as our width. Anything that is perpendicular, this is our depth, right? So Izz now so is equal to, for a rectangular, is width, depth, cube divided by what? 12. So Izz width is equal to B, depth is equal to 2C cube over 12. So this will eventually be equal to 2 or 8 BC cube over 12. So this will be equal to 2/3. Okay, 2/3 BC cube. So from this formula, we know what is our V. We know what is our IZZ. Next, we are going to calculate our QZ. Right? So QZ, as we said earlier, is equal to A